Okay, as I was saying, when you have a radical expression, we can convert that to an exponent. And what we do is we take the number, the exponent that's inside the radical sign, and if there's no number here, what number can we pretend is here? 1. And that number becomes the numerator. The index, that becomes the denominator. So for example, if I want to write the square root of 36 as an exponent, this is 36 to the first power, and this is a little 2 because it's a square root. The numerator is the number that was inside the exponent that was inside the radical sign, and the index becomes the denominator. Doesn't matter what the index is or what the exponent is, that's the conversion. So the cube root of 64 converts to 64 to the 1/3 power, and the fourth root of 16 converts to 16 to the 1/4 power. What I did is I created a tiny little mnemonic device to help you remember. Does anyone know what a mnemonic device is? It's a helpful device. Yes, thank you. How is it helpful? What does it do?
Sticks in your brain.
That's right. A mnemonic device is something that, some phrase or word that you say that sticks in your head that helps you remember what you actually wanted to learn in the first place. So for example, those of you who know music, you may remember the notes of the scale, every good boy does fine, which are the E, D, every E, G, D, F, B, F, every good boy does fine.
D.
E, G, B, D, F, every good boy does fine. So you remember every good boy does fine, and the first letters of each of those words tells you the notes of the scale. So the one that I came up with is that the numerator stays with the number. Numerator and number. What I mean by that is if I have an exponent, say 216 to the 1/3 power, and I want to convert that to a radical, the numerator stays with the number. The 1 stays with the 216 inside the radical. And the 3 becomes the index. Now when you're writing it, you don't have to write the 1 for the exponent. You can if you want to. But then we say that then we can figure out that the cube root of 216 is 6. Same thing if we're multiplying. If I have 7 to the 1/2 power, and I want to multiply it by 7 to the 1/2 power, I can convert those to radicals. Well, anything to the 1/2 power is the square root. That's a good thing to remember. It will come in handy. It will save you some time. Just anything to the 1/2 power is the square root. 7 to the 1/2 power times 7 to the 1/2 power is the same as the square root of 7 times the square root of 7. The square root of anything times itself is simply that value under the radical sign. Notice I can also say 7 to the 1/2 times 7 to the 1/2. The bases stay the same. What happens to my exponents when I multiply? You add them together. 7 to the 1/2 plus 7 to the 1/2 gives me 7 to the whole, or 1. 7 to the first power is simply 7. Okay, does anybody have any questions so far? Is there anybody not done copying? Now, if I want to multiply two radicals together, two exponents together, first thing that I'm going to do is rewrite them as radicals, which we just learned how to do. So anything to the 1/4 power, notice the numerator stays with the number, and the denominator becomes the index. So 5 to the 1/4 power can be rewritten as the 4th root of 5. 125 to the 4th root to the 1/4 power can be written as the 4th root of 125. Okay, we've learned that if my indices are the same and I want to combine two numbers under the radical sign, I can just multiply them together.
Is this another example?
What?
Is this another example of the thing?
No, it's another example of something different. It's a new thing. So I multiply the two radicals. You'll notice I've skipped this intermediate step. I don't think it's necessary. If you feel more comfortable doing it, by all means, please don't let me stop you. Just as once you reach this step, once you multiply 5 and 125, and you get 625, I don't feel it's necessary to simplify it this way. If you understand that the 4th root of 625 can be rewritten as 5 to the 4th power, and then you want to go ahead and do your division, do the 4th power divided by the 4, gives you 5 to the 1st power, that's fine. My feeling is that once you reach this step, once you reach the 4th root of 625, it's going to be much easier just to plug this into your calculator and go directly to the answer. There's no reason to simplify this, because in all likelihood, you guys are going to have to plug this into the calculator to figure out what the root is anyway. So if you're going to bother to plug something into your calculator, you might as well go right to the answer. Now if you happen to know that 625 is 5 to the 4th power, and you want to rewrite it to make the rooting, for lack of a better word, simpler to visualize, then that's fine. Because if you have a 4 here and a 4 here, and you divide your two 4s, you end up with 1, 5 to the 1st power. But like I said, I don't think that you necessarily need to do that step. Once you reach that 625 to the 4th root of 625, I would go ahead and just put it in my calculator and get my answer. Why give yourself extra work? Questions? Comments? Concerns? Not done copying? Okay. All right, now you've noticed that so far all of the exponents we've been working with are all 1/2, 1/3. They all have a numerator of 1. Now we're going to convert when the numerator is something other than 1. So here my example is x to the 3/7 power. Now the way we do it is exactly the same. So don't be thrown off by the fact that 3/7 and not 1/7. The numerator stays with the number, and the denominator becomes the index. So what would this be written in radical form?
Or the cube root of x to the 2nd. Or the cube root, the 7th root of x to the 3rd.
That's right. The 7th root of x to the 3rd power. Now notice, I have another way that I can represent it. I don't have to put the exponent inside the radical sign. What I can do is I can put the radical in parentheses and put the exponent outside. So in other words, I can say this one of two ways. I can either say that I can raise x to the 3rd power and then take the 7th root, or I I can take the 7th root first, get an answer, and raise that to the 3rd power. Now, depending on what your problem is asking you will determine which way you should use, because it's going to be easier one way or the other. So I put a little example up on the board, and I put 343 to the 2/3 power. So I have two ways that I can express 343 to the 2/3 power. I can either write it as the cube root of 343 squared, or I can write it as the cube root of 343, and then that quantity squared. Now, for me, this is really hard. 343 squared. I don't know if you can figure this out off the top of your head. You're a better mathematician than I am. Okay, what is it?
It's a whole number.
It's a whole number, thank you. It's a really big number.
Yeah, it does.
Thank you. So, you can do that. You can square it and then take the cube root, but what happens is, you're going to take 343 and square it, and you're not going to know, maybe you hit a key wrong. You're just going to have to rely that the calculator is correct, that you didn't make a mistake. On the other hand, you might actually know what the cube root of 343 is. You may know your perfect cubes. And you might know that the cube root of 343 is 7. And then if I square 7, that I know I can do in my head. 7 times 7 is 49. So in this type of problem, usually if the number is really big, you're going to be better off finding the root first and then raising it to a power. Whereas if the number is small, you're going to be better off raising it to a power and then taking the root. Okay, so if I want to write, the 5th root of b raised to the 3rd power as an exponent, what is that exponent going to look like? b 3 over 5, otherwise known as b to the 3/5 power. But that's correct. Bless you. How to convert that to a radical. And that is y to the negative 3.5 power. Seems pretty ugly. Negative 3.5. Ew. What? What? You could. You would be wrong, but you could. Well, you can try to cross I-75 on foot. You will probably get smushed like a bug, but you can do it. Remember, if you can dodge a car, you can dodge a ball.
Oh, I thought you were going to say a bullet. And that's going to start singing.
And if you can dodge a wrench, you can dodge a ball. Dodgeball. Ever seen the movie Dodgeball? Anyway, okay. We have a number of rules in math, as you know. One of the rules is just like never start a land war in Asia. That's a blunder, by the way, not a rule. We don't deal with negative exponents, and we don't deal with decimal exponents. So first we're going to have to convert this to a fraction, and then we're going to have to convert it to a positive number. So how do we convert negative 3.5 to a fraction? See? Okay, you can convert negative 3.5 to, and we're going to ignore the negative sign for a minute, to 3.5. And how do I rewrite 3.5 as a fraction, an improper fraction? No. That would be 3 halves. What?
Oh, no, that's way off, sorry.
7 over 2. Multiply the numerator times the denominator by the value. Get 6, and then add 1. Get 7 halves. Turn your decimal into an improper fraction, or I guess this is a mixed number, I should say. To turn a mixed number into a fraction, multiply the whole number by the denominator. That's 3 times 2 is 6. 6 plus 1 makes 7. Yes. I ignored it for a minute. For converting from a decimal to a fraction, I don't need the negative sign. Once I convert it to the decimal, to the fraction, yeah, put the negative sign back in. Okay. Once I have my negative fraction, rule number 2 is we don't deal with negative exponents. So what I have to do is I have to convert this negative 7 over halves into a fraction. So what we do is 2 steps. Number 1, we take our value and we turn it into a fraction with 1 in the numerator. So I take my negative 7 over 2 and I turn it into 1 over negative 7 over 2. Again, I take whatever my fraction is and I turn it into a fraction and put 1 in the numerator. Step number 2 is I take my negative exponent and I turn it into a positive exponent. So negative 7 over 2 becomes positive 7 over 2. So to turn negative 7 over 2 into a fraction, take it and put it under 1, make 1 the numerator, and then make the negative into a positive. So negative 7 halves becomes positive 7 halves. Now what I'm going to do is I'm going to take my take my exponent and turn it into a radical. The numerator stays with the number, the denominator becomes the exponent, so I get the 1 over the square root of y to the 7th power. Okay, now I'm sure you would like to think that we're finished, but you would be wrong. Because we have that other rule that we talked about. No radicals in the denominator. That's right. No irrational numbers in the denominator. Okay, is there anybody not done copying what's on the board? There are two ways that we can go about rationalizing this denominator. I'll go over both ways. I'm going to go over the easier way first, so if we run out of time, at least you'll have that way to use on your homework. Okay. In order for me to get rid of this, I need a perfect square. So I already have 7 y's. How many more y's do I need in order to make this into a perfect square? I need 1 more. Remember, my index is 2. When I deal with indices, perfect squares are multiples of 2. So I'm going to multiply this by the square root of y. If I multiply the denominator, I have to multiply the numerator. Now I'm going to multiply. This is exactly what we just did, guys. You should be able to tell me what to do. Or maybe not. y to the 7th times y to the 1st is y to the 8th. The square root of y to the 8th, y to the 4th. Okay, now the other way is more complicated, but you might want to do it. And that is simply to multiply by itself. So what do I get? I get the square root of y to the 7th divided by, this is the square root of y to the 14th, which gives me the square root of y to the 7th over y to the 7th. But I still have to, I can simplify this. I can turn it into two piles, y to the 6th and y. I'm sorry, this should not be a radical. This should just be y to the 7th. The square root of y to the 6th, y to the 3rd. So I get y to the 3rd times the square root of y divided by y to the 7th. And then what can I do with the numerator and the denominator? I can get rid of 3 of the y's. I get rid of all these y's, and I can get rid of 3 of those y's, which gives me square root of y over y to the 4th. Do I care which way you use? I do not. Do I have a preference do I have an opinion as to which way you should use? I do. That's the top way, because look at the difference in the number of steps. 1, 2, 3 steps versus 1, 2, 3, 4, 5, 6. Anytime in my life that I can do something in 3 steps instead of 6 steps, that is something I will do every time. I'm lazy. Does anybody have any questions?